basic data types in Python. So in Python, as in other programming languages, you can have a value like 5, and these values can have different types. So for example, you could have an integer, 42, for example, or a string, hello. And we can also have variables that are storing some sort of value in it. So like x equals 5, x is a variable, it's storing 5. You can do stuff to it, all that kind of thing. So we can name the variables. Most things in Python, there's some restrictions. It needs to start with a letter. In R, you can use a period in variable names. In Python, you cannot use a period in variable names. And there's some special words that you cannot or should not use as variable names, for, if, those kinds of things. The most annoying one, let me add it to the list, is lambda. Often you would actually like to name your variable lambda, but you can't because it is a reserved word in Python. So here is a table of some data types that we're going to talk about today. So you can have integers, you can have what are called floating point numbers. We're going to go into that in a lot more detail in a future course, but other numbers that are not integers that are stored to a bunch of digits of precision after the decimal. Boolean values, meaning true or false. Text, lists, tuples, dictionary. So we're going to talk about all of those things today. And you can refer to this table if you want to have a quick reference. And then there's also a special type called none. So let's get right into it. This Jupyter notebook is posted in that 511 students repository that I showed you earlier. So if you want, you can download it, fire it up in Jupyter, follow along, run the code as I'm running the code, or you can totally not do that. You can fire it up and just watch the lecture, or going back to here, oops, misclick. You can just click on this link, and the notebook will just get rendered in your browser, and then you could follow along in your web browser, but you will not be able to run the code if you do it that way. Okay, so I can store 42 in x. I can look at the type of x. It's an integer. I can print it out. It prints out as 42. In this Jupyter environment we're in, you can just type x by itself, and it's going to kind of print it out by default. That wouldn't work if you were writing an actual Python script and you just had a line that said x. It wouldn't actually print it out. You have to type print x. But in this Jupyter/IPython thing, which we're going to use a lot of, you can just type the name and it'll print by default. And I think there's something analogous in R. So we can store this thing, which is not exactly pi. We can print it out, look at the type. In this case, it's a float. And again, we'll talk more about floats later. By the way, we should be able to actually make a variable called pi. Yeah, so if you want to do that, in Jupyter, you type \, and then whatever Greek letter thing you want, and then you press the tab, and you can actually get variables named other kinds of characters. So that's the most useful for lambda, because we cannot actually name a variable lambda. Okay, so what can you do to these numbers? Well, the usual stuff. Add them, subtract them, blah, blah, blah. The one weird thing in Python is that exponentiation is ***. In most programming languages, it's the caret thing, shift 6, if you will. But in Python, it's ***. And then there's some more obscure operations that we will rarely need, but maybe sometimes. So integer division, // and modulo is the percentage sign, which I will show in a minute. So you can just do normal stuff, add a bunch of numbers together. This 0.1 plus 0.2 not being quite 0.3, again, that's something we're going to talk about in a later course. Okay, so you can multiply stuff. And again, this 2 star star 10 means 2 to the power of 10. I should point out that this thing is an integer. Just a minute. This thing is an integer, whereas 2.0 to the power of 10 is a float. That distinction will occasionally matter just in the way like super giant numbers are handled and stuff. So in general, in Python, if you want to have a number that is actually an integer in your brain, but have it stored as a float in Python, you can just type 2.0 or even just 2 point without the 0, and that'll tell Python, make this a float. So 2 int, oh wait, yeah. That's an integer, and that's a float. So there you have it. Okay. So you can divide stuff. 101 divided by 2 is 50.5. This integer division thing I was talking about earlier, it divides, but then it just throws away whatever was after the decimal. Occasionally useful. That's also how division behaves in other languages like C or Java or whatever, if both things are integers. And you can reproduce that behavior in Python like this. Okay. And this mod thing, the % sign, probably won't need to use it that often, but if you haven't heard of it, it's the remainder when you divide two numbers. So when you divide 100 by 2, you get 50, remainder 1, so the thing outputs 1. Any questions or comments so far? Okay, 3. So I'll start with you. What's your name?
Anas.
Anas?
Yeah.
Okay.
So when you did 0.2 plus 0.1 plus 0.2, you got 0.3004. Like it's messing up the precision.
Yeah. The question was about this weirdness over here. So Anas, you're going to have to wait like 4 months to satisfy your curiosity about this. We are going to talk in excruciating detail in January about what's going on here. For now, it will not affect your life in any meaningful way, and you can just assume it works. Yeah. Okay, there was another question. Yeah, what's your name?
Ryan.
Ryan.
When you did the symbols, like using lambda and delta,
Yeah.
do you advocate or recommend actually doing that to
Yeah, so Ryan's question was, do I recommend using these weird variable names like lambda? Not really, because there's like different fonts, and you can get two things that to me look exactly like lambda, but they're actually different characters under the hood. And then like you do lambda equals 2 and print lambda and it's 5 because it was like the other font. It's totally ridiculous. So do I recommend it? Probably not, but it's kind of cute and nice to know it exists. And for lambda in particular, it's just annoying that you can't name a variable lambda, but I'm not a big fan overall. And also someone else might not know how to input those conveniently, or they might not be using Jupyter, and yeah. Okay. Your name?
Serge.
Serge.
Do integers and floats in Python behave like objects, or just like numbers that you like? I mean, can you do, for example, 1 dot like something?
Yes. The question is, do integers and floats behave like objects? So let's defer that to next week. We're going to talk in more detail about that kind of stuff next week. Any other questions? Yes, what's your name?
So, Leslie.
Leslie.
So when you made the character for like sigma and pi, that only works in Jupyter. No.
When I made the character for sigma and pi, does that only work in Jupyter? So the code is going to run, period. It's not like the code is valid Python code. It's just a question of the thing you're using to write down your code, does it have convenient shortcuts to make those characters? And Jupyter does, and some other editors do, but some others don't.
Okay. So like if we're in Spider, it might not work.
Well, yeah, if the code will work, but it might be annoying to input those symbols. Okie dokie. Right. So those were numeric types. None is a special type that only has one value. Most types, like integers, have a lot of possible values, 1, 2, 3, whatever. The none type only has one possible value, none, and you may have seen similar things in other languages like null or whatever. So here it is, x equals none, none type. That's pretty much all there is to say about that. Okay, strings. String means basically text, like a bunch of characters. And there are 4 ways you can literally specify strings in Python. Single quotes, double quotes, triple single quotes, and triple double quotes. So this is now a string. I can print it out. The type is str, which is string. I use double quotes here. I use single quotes here. I can't start it one way and end it the other way. If I start it with single quotes, I have to end it with single quotes. Here's the oops. Print course, type course. So why do they bother with this? Well, for one thing, if you want to use the apostrophe character, aka single quote character, then you can just enclose it with double quotes, and then the apostrophe is just going to be an apostrophe, and so that's kind of convenient. Until, of course, you want to use double quotes and single quotes in your string, and that's where the triple quotes come in. So the triple quote says everything after this, just interpret literally until you hit another triple quotes. And so then, unless the thing you're actually trying to say has triple quotes in it, which seems pretty unlikely, it's just going to work with single quotes and double quotes in the string. So that's the point of it. I can't really say there's a point to having triple single quotes and triple double quotes. I think one of those would have been enough, but probably just for symmetry, the creators of Python, I guess, decided to allow both. Questions? Yeah, your name again?
Anas,
Anas.
if I'm not wrong, with like triple quotes, you can sort of like extend it to a new line without.
That's correct. So triple quotes are so literal that you can have a new line in it. And in the back end, it's just a new line character. It's just a special character that when you print it, looks like a new line. So yes, that's a pretty big convenience of the triple quotes. Okay, Boolean. So Boolean is named after someone named Boole, as far as I know. There's only 2 possible values, so just slightly more interesting than none. True and false, those are the 2 possible values. So in Python, to literally say true, use a capital T. I know in other languages use a small t. Capital T for true and false. I can store that in a variable. I can query the type of that variable. Bool is the shorthand for Boolean. And I can do the same with, sorry for the scrolling. I can do the same with false. So, okay. Not too exciting yet. Next thing, comparison operator. So an operator, actually we were doing operators before without saying it, like plus, minus, that kind of thing, operating on these values. So this is quite similar to other programming language. So double equals sign to check if 2 things are the same. A very, very common mistake is confusing the double equal sign with the single equal sign, which is maybe one reason why R doesn't use the single equal sign for assignment, as you'll see in a couple of weeks. But anyways, in the Python world, x equals y is not saying set the value of x to the value of y. It's saying, are these 2 things the same? And then that expression gets evaluated to the result. And when you say 7 plus 3, that expression gets evaluated to the result 10. And when you say x equals y, that expression gets evaluated to the result, which could only be true or false. So when you add 2 integers, say you're going to get an integer out, when you equals two things, you could only possibly get two things out, true or false. Not equal to, greater than, greater equal, less than equal to. Is, we'll talk about is more next Tuesday and how it compares to equal. Okay, so 2 less than 3 is true, I hope. Data science not equal to deep learning is true, I hope, although I have to keep telling people that over and over again. 2 not equal to 2, so this one, what do you think?
False.
Okay, I heard both true and false.
No false.
So this is false. It's the integer 2 and the string 2, so they are considered not equal. But, I mean, it wasn't like the craziest thing to say true. You can't just say they're different types, therefore it's false, end of story, right? So it's a bit of a just, okay, let's get used to how the language behaves. Good. Okay, it's just people would go insane if this last one was not true because you're not always that careful of keeping track if your stuff is an integer or float. Okay, so you can combine, I wouldn't say combine operators, I would say, let me change this. Operators on Boolean values, that's how I would prefer. In fact, let's start like this. True and false is false. It is. Okay. This thing is returning true because both things on either side of the and are true. The next one is returning false because what does and mean? It means this and that, and well, the one on the right is not happening. So it returns false, and you can, imagine how it works. But really in life, most commonly, the way you would be using and, or, etc. is with some compare type stuff on the left and some compare type stuff on the right. Is x equal to y and x, z equal to a or whatever. But I just wanted to point out what's actually happening here is first, Python 3 not equal to Python 2 is happening. That is true because they're not equal. 2 less than or equal to 3, that is true because they're not equal. In your brain, you should think about that happening first, and then true and true is happening after that, and that's why it's returning true, I hope. So yes, I'd love you to be thinking about, in your head, step 1, do the stuff in the parentheses, and then step 2, do the and. Because that is actually what Python is doing. And then there's not, okay, maybe start with something less weird. Not true is false. Not true is true. Questions or comments? Okay, casting. So cast is when you just explicitly say, I want to turn this thing into this type. That's what the word casting means. So I want to cast 5.0 to an int. It's telling Python, here's 5.0. It's not an integer yet. Just try to make it into an integer in some reasonable way that you deem sane. And so in this case, it's pretty obvious, just turn it to 5. It's not going to turn 5.0 into 4, because that would be ridiculous. So it turns 5.0 into the integer 5. However, well, not however yet, however soon. So turn 5.0 into a string. That says, OK, I'll just turn it into the string 5.0 or 5.0. That's all good. And now it's a string. We talked about this before. Actually, we did quote 2 equals 2. That was false. But here you say turn 5.0 into a list. Well, I guess you could make it a list. Well, we haven't even talked about lists yet. We are about to. But I guess you could make it a list with one element in it that is 5.0. But that's going a little overboard here. So Python is just going to say, no, thank you. And that's actually good, right? It's good for the language to say, hey, you probably made a mistake. Can you look at this more carefully and write a bit of extra code to say what you actually meant. And Python and R, some of the weaknesses of Python and R, in my opinion, are that they often do too much to guess what you intended, which makes them a little more error prone compared to, say, Java, where it's like, okay, yeah, it's a pain because you have to write down every little thing, but at least you made sure you thought it through. So we have to be careful when these languages just go ahead and decide that you meant this, right? And at least here, it would be going too far if it turned 5.0 into a list. So at least it says, hey, what's going on here? Throws an error. Yes, what's your name?
Carrie,
Carrie.
if you were to turn like 5.3 into an integer, would it just take off the decimal?
Ah, great. Yes, if you were to turn 5.3 into an integer. So it would just turn into 5, and we can say it's a philosophical question whether that is sane or insane. But I guess this sort of has roots in other programming languages too. Yeah. You will not end up casting things very much in your life, I would predict. It's just sometimes you have to, and it's good to know that it's possible. Okay, next. Lists and tuples. So far, all of our variables, x, y, whatever, lambda, have just stored a thing in them. 5, hello, etc. But there's also data types in Python that can store multiple things in them, which, as you can imagine, is often desirable. So here is a list. It contains 1, 2, 3, 4, and 0.5. And I have used square brackets to tell Python that it is supposed to be a list. Okay, so here it is. It's all good. And the type is a list. So the key thing to notice here is that the elements of the list do not need to be the same type as each other, which you may be used to from arrays in another programming language or something. You can just put whatever you want inside of the list, including other lists, including weird objects that you've defined next week, those kinds of things. Just anything. Okay, so we can get the length of the list with len, which is short for length. Yeah, we've been kind of doing it without saying it, using these parentheses to call functions. We'll talk about functions on Thursday. But there's something called len that says, hey, this list has 5 elements in it. Now, notice this is pretty, well, let's just make it the exact same thing. Make it a more controlled experiment. So this is the exact same thing, but with parentheses instead of square brackets. And that's all good. That's all good. And this thing is called a tuple. So tuples and lists are quite similar in Python. I'll talk about the differences in a second, but here they are, and you use different types of brackets to specify them, and you can do similar stuff like len to get the length of the tuple. Questions? Okay. So slicing and indexing, in other words, getting stuff out of the lists. That's what this means. So here we go. Here's my list. Here's my list 0. It returned 1. So what's going on here? Python indexes from 0 like the majority of programming languages, I would say, meaning the first thing in the list is referred to as element 0. The second thing in the list is referred to as element 1, etc. The reason why this is a bit painful is that it's the other way around in R, that R starts with 1. It just depends on the language and what the language was designed for and what community of individuals created the language. But that's just going to be a thorn in your side that there's no way around, and you'll just kind of get used to it over time. So if I want thing number 4, it's giving me 0.5. And if I want thing number 5, it's saying, no way, there is no thing number 5, which is annoying because there are 5 things, but just remember that the element 5 is actually the 6th thing, and there is not 6 things in the list. And we'd use the square brackets, so both to create the list and to so-called index into the list, get stuff out of it. And it's the same for the tuple. So to get stuff out of a tuple, I would also use the square brackets. Ah. Oh, I called it. Ugh. Okay. Not a relevant variable name, but anyways, yes. So you use the square brackets to index into the tuple as well. Okay, fancier things. So you can use index -1, which in Python means get me the last thing in the list. So when you put the negative sign there, it means I'm counting backwards from the end, but frustratingly, when you're counting backwards from the end, now it starts at 1. I'm sorry on behalf of the universe or whatever, but counting forwards, you start at 0. Counting backwards, you start at 1. So -1 means get me the first thing from the end. -2 means get me the second thing from the end. Let me just remind you what is in here, etc. Yeah, what's your name?
Annie.
Annie.
So what do you do when you want to get the last thing on a list in R?
Tiffany?
You probably want to think they don't use the -1s, so you want to figure out how long the thing is
Right.
using the length command, and then you have to index using that.
Yeah, so it'd probably be something like this in R. This would throw an error in Python because there's 5 things and there's no element 5, but this in R should work because it starts from 1. So if there's 5 things in the list, then thing number 5 actually exists. Let us strike this from the record. Okay, right, so we can also use a colon to so-called slice or grab a bunch of things from the list at a time. Again, there's just a bunch of things you have to get used to and remember. So when you say 1 to 3, it means get me thing number 1 and thing number 2, but not thing number 3. What can you do, right? So that we say it is inclusive at the start and exclusive at the end. So I could say 1 to 4, and then it would get me, well, you get the idea. You can also omit things, so just :3 means get me everything up to but not including element number 3, and 3: means get me element number 3 and everything after it. So, yeah. There is a certain elegance to the fact that :3 and then 3: put together gives you everything, which is, I think, why it's inclusive on one side and exclusive on the other side, but it's also just a pain. So any questions or comments about this? Your name?
Alexander.
Alexander.
What's the difference between lists and tuples?
Coming. The question is, what's the difference between lists and tuples? Maybe should have said it immediately, but coming in the next 5 minutes. What's your name again?
Furkan.
Furkan.
So my question is that in Python, how can you define arrays? Are they defined using lists?
Yeah, the question is how do we define arrays in Python? We are going to talk about that next Tuesday when we talk about NumPy, which is the part of Python dealing with numerical arrays and stuff. Okay, yeah, there's also just my list : we'll just talk about that later. So another thing is that strings are actually basically, you can kind of think of them as lists of characters. So everything we just talked about for lists, you can do for strings. So this gets me the first letter, this gets me the last letter, the third from last letter, the letters up to and not including letter number 5, letters 12 to 20, etc. Okay, list methods. So there's a bunch of things you can do with lists. We already talked about the len to get the length. Another pretty common thing you would want to do is add something to the list. So if I append 13, just running this line of code adds 13 to the end of the list. So if I print out primes again, it now has 13 on the end. And by the way, if I just run this cell like a bunch of times, then I have now, oh yeah, now I have a lot of 13s at the end. So every time I run that, I'm appending 13 to the end of the list. Length is now 22, and there's other kinds of methods you can do. So what is the biggest thing? What is the smallest thing? What is the sum? That kind of stuff. I should say one other thing, which is that you can actually add lists. So you can do this. I don't know, 7. So in Python, the plus operator concatenates two lists together, which is just a handy convenience. But again, weird. Like, if that's what you meant to do, it's great. But if you thought your thing was a float, but it was actually a list, and then you tried to add it because normal people add numbers, and then it just doesn't throw an error and adds two lists, then that's sort of the danger underlying all the convenience. But it is what it is. Okay. Next. Oh, yes. Name?
Sam?
Sam.
Is there a trick to remember when a method actually like changes the variable?
Oh,
or when it just...
Beautiful question. The question was, is there a trick to remember when the method actually changes the thing? So no, and that's kind of a crime because, like, if you just told me you wrote some function in Python, like, or method, I guess I should say in Python, the first thing I'm going to ask you is, does it change my stuff or not? Like, I want to know that before I start using it, right? So in other languages, like there's a newer programming language called Julia, they have a naming convention that you end the name of the function with an exclamation mark if it changes the thing. And that's not like, I think it's just a convention, but that makes so much sense. Like, you would really want to know that. So the solution here is that as we start writing these functions, methods, whatever, on Thursday, we are going to make sure to clearly write in words what the thing does so that anyone using it can go and read that and not get their stuff messed up. So we're going to talk about that on Thursday, and we're going to be pretty strict in this program about documenting, writing down what your stuff does, and that's such a great example. It's just not okay if your code is changing other people's stuff without saying that it does. So yeah, if you went into the Python documentation and read about append, it would say it changes the list. Other questions? Name?
Shivam.
Shivam?
Yeah. What if we were to add two lists, like 1, 2, 3, 3, 4, 5, we have to add element by element.
Yeah, the question is, what if we want to add two lists element by element? We'll talk about that next Tuesday, but that's just easier done with NumPy. Okay, next thing, sets. So sets are literally defined with curly braces, so now we have square brackets, parentheses, and curly braces. And sets are very different from lists and tuples in that, first of all, there is no order to the elements. So let's see. 1, 2, 3 equals equals 3, 2, 1. True. 1, 2, 3 equals equals 3, 2, 1. False. So with lists and tuples, they are maintained in a certain order. With set, there's no order, so those two sets are the same. And sets are just maintaining unique elements. So if I have this set 2, 3, 5, 11, and I add 2 to it, it didn't get changed because 2 was already in there, so putting 2 in there again doesn't do anything. Sets are super useful, and you'll be seeing them throughout the year. And right, this is going to throw an error because there is no element 0 of the set. The set has no order to it. So we'll see over time why this is useful. Okay, now getting to the question of what is the difference between lists and tuples. They are quite similar, but lists are so-called mutable and tuples are so-called immutable, which just means lists can be changed and tuples cannot be changed. So for example, that append to a list that we just talked about, that was changing the list. You cannot change a tuple. It is just stuck there forever. You can do operations on it which create a new tuple, but you cannot actually change that tuple. So there's no like append thing. So sets are mutable, as you just saw. It has an add function, but strings and tuples are not. So here's some code. Just a second, Serge. So we got a list, and I can set element 0 of that list to something else. And I've actually changed names list with that line of code. So this line of code right here actually replaced that first element from Indiana to cool guy, whereas with the tuple, it's just going to throw an error if I try to do that. And same for strings. Okay, Serge.
Yeah, thanks. So what's the benefit of using tuples versus lists?
Yeah, what's the benefit of using tuples versus lists? It's just sometimes you know something shouldn't be changed, and so you just make it a tuple, and then you can rest at ease. So for example, if I'm passing to Sam's function, I don't really trust him, better give him my tuple, and then I know he's not going to mess with it. I mean, that's a bit silly, but it's sort of like that. There are times in programming where you would like to know something's not going to happen, and if you can just enforce that, life is a bit better. Okay. Yes, what's your name?
Simmer.
Simmer?
Yes.
Okay.
So you said that list and tuple are same, except list is mutable and tuple is immutable.
Yeah.
In the beginning of the slide, it's written homogeneous sequence for list and heterogeneous sequence for tuples. Like, is this something for data types?
Yeah, let us just solve that problem in the following way.
In the very beginning of the slide.
Oh, what?
Like in the very beginning, it's mentioned that homogeneous sequence for list and heterogeneous sequence for tuple.
I don't know what you're referring to.
Very beginning.
Like all the way at the beginning?
The description of all the data types.
Oh, okay. Here we go. Everyone get ready.
The table.
Going up, going up.
Yeah.
Okay, yes. Let us just solve this problem by saying a collection of objects, mutable, and a collection of objects, immutable. And let's say ordered here too. Great. Okay. Ryan?
Yeah.
Yeah.
If I have a function that takes a tuple and I have a list, can I call the function with the list, or does it get passed automatically?
Okay, yeah, so, well, let's defer that to Thursday, except that saying in Python, you don't really have to say what type something is, which is both good and bad. You may, if you come again from C, C++, whatever, you might be used to int x equals 5, and where is that? So we just don't do that. It's called static typing versus dynamic typing. So one of those things, again, where Python's very loosey-goosey, that has its pros and cons. I'm personally not such a big fan of that, but it's, again, very convenient. Yeah, so your name?
Akansha.
Akansha.
If you put a list inside a tuple, is it still mutable?
Yes, if you put a list inside of a tuple, we can do that just for kicks.
And it is not working, so
Sorry if anyone's warping into another dimension here. Okay, so you could have a list with a tuple in it. Say, now x is mutable. I could replace that tuple with something else. I could replace 5 with something else. But the first element of x, which doesn't currently have a name but still exists, is not mutable. So I could do this, but I could not do, say, this. I could not change element 1 of the tuple because the tuple is immutable.
And what if vice versa? What if it was like a tuple and inside it held a
Yeah,
list?
the usual rules just apply. You cannot change the tuple, but you can't. I see. Okay. I see what you're saying. I hear you. You're saying, can I change this list? Because if I did, it would kind of be like changing the tuple, and that's not allowed. So I think you will be able to. Right. It worked. And to really understand why that was allowed, we're going to talk about that on next Tuesday more, which is like, how are these things really stored under the hood, and what is X and what is that thing? So
the list is probably a reference.
we'll get to it. Okay, let's take a break. So let's resume at 11:50. Next thing, string methods. This might be kind of elementary for the computational linguistics students who are going to be doing string things all day long, all year long. But just some basics of string methods. Here's a string. Dot lower just takes everything, puts it to lowercase. That's useful because if you want to compare if two strings are the same and you want to make it case insensitive, just call dot lower on both of them, and then you can check if they're the same. So that's really useful trick. Note that dot lower, yes, right. So we already said strings are immutable. So dot lower just gave us a new string. It didn't mess with the old one. So if I said new string equals, right, then the point is all caps, the old string still exists in its previous form. It never got changed. We just made a new string called new string. Whereas if it was a list, the original thing could have actually been tampered with such that the original variable actually now had the new stuff in it. Again, more coming on Tuesday. So there's all kinds of things you can do with strings. Split. It's impossible to memorize all of these things. You'll just end up looking them up as you need them. But you can count how many O's are there. There's 3 O's. Now casting, we talked about casting earlier. So can I turn a string to a list? Is that a sane or insane thing to do? It's deemed sane because, as I was saying, strings behave a lot like lists in Python. They're just a sequence of stuff. So here, when you cast it to a list, it becomes a list where each element is a character. And so the length of the list is equal to the length of the string. So caps list. String formatting. So it is pretty common that you want to write something, you want to print stuff out to the user often, and you want to like make a string out of different parts, like the value for X is like 17, and you're getting 17 from some other variable and X for some other variable. So there's 2 ways of doing this in Python. There's the old way of doing it, which is sadly the way I do it out of habit, because I come from other programming languages originally. But the way that works is you put these weird percent things in the string. So %s says that is going to be turning into a string later on. And %f means that is going to be turned into a float later on, printed out to 2 decimal places. And then you do this % thing to it, which is really horrible because we already said % is modulo, and now we're using % for some unrelated task. And then we pass it a tuple. And so it takes the first thing in the tuple and puts it where the %s was, and takes the 4/12 and puts it where the f was. And you get this, which is admittedly like a useful thing that you might want to do. I do it all the time. But this, again, is one of those things that you just do it enough times and you kind of remember how to do it, or you look it up if you don't. So that's the old way. And then the new way is to use curly braces with some rules. But again, point to f F is for float, and 0.2 is saying to 2 decimal places. And then you use dot format instead of the percent, which I prefer. Template, new, let's say, and you get the same thing. So if you've been programming in C for like a long time, you might just want to do the first thing because you're used to it. And if you're not used to either of them, you might as well learn the new thing, because that's what people do these days in Python. And this break had been moved earlier. Please excuse the interruption. That's when we did the break. Okay. Any questions about this string formatting? Yeah, what's your name?
Bronwyn? What's
Bronwyn?
semicolon do?
The semicolon.
In the new formatting stuff.
Oh, you mean the colon?
Sorry, yes, I mean the
Yeah, I don't even know, because I just don't use it, but I should know if I was doing my job slightly better. We can look it up and read what those things do. Yeah, Sam.
It's like common. It's actually like a way that I think is easier to do it now. It's called F strings.
Oh, yeah.
It's the most intuitive.
That's right. I forgot about that. Okay. Yes. I think I heard about something like that. So to do, Sam claims there is something newer, better called F strings. We'll look this up. Okay. Great. All right. Dictionary. So dictionaries are an extremely useful data type, and what they represent is a mapping. So how should I say it? So in lists, we just had a bunch of stuff. Element 1, element 2, element 3. You could think about dictionaries as, instead of element 1, element 2, you have mapping 1, mapping 2, mapping 3, where, say, I'm storing some properties of the house, so the mapping from bedroom, the number of bedrooms is 3. That's what you're trying to say. But in other words, each thing that you're storing has a name. Maybe that's a good way of putting it. So in lists, you just have the first thing, the second thing, the third thing. But in the dictionary, you have the bedrooms thing, the bathrooms thing, the city thing. So each element gets a name instead of just being in order. And so you can do dictionaries on one long line like that, or you can do them more human readable like that. Either way is fine. And there's no order to dictionaries. It all goes by the name. So you can't say what is the first thing, what is the second thing. You can just say what is the city thing, and it'll say Burnaby. So a bit confusing because curly braces are used for both sets and dictionaries, but it just figures out what you mean because here we have these colons that make it clear it's a dictionary. I did know your name, but I forget.
Tom.
Tom, okay.
Does it work backwards if you do like house 2? Will it bring up bathroom?
No. Oh, no. Good. Yes, right. So when you're fetching things, you can say, tell me the number of bathrooms, and it'll say 2, but you can't say, tell me the thing that there's 2 of them, and it'll say bathrooms. And in fact, to kind of drive home that point, it's definitely fine to have the same number of bedrooms and bathrooms, but this would not make any sense. Okie dokie. So the way we access things like list, tuple, we use square brackets to access things, but instead of saying the 0th element, we say the price element, because again, we're referring to the elements by names, not by numbers or index. So tell me the price of the house, tell me the city of the condo, and you edit things just like you would edit a list. We saw earlier with the list, you could say x square bracket 0 equals 5. That means set the 0th element to 5, and it's the same thing here, except again, you're referring to a name. Now, if flooring was already in there, so let's do 2 things. Let's do so I can set something that's already in there, and it just overwrites. overwrites the value, so now price is 5, or I can just add something that was not in there, and now it actually adds a new field called flooring. Both of those are valid. Okay, also I don't do this much, but there is this syntax in Python, del, to delete one of the fields. Sure. Okay, questions about dictionaries? Name?
Andres.
Andres.
All the names of the dictionary have to be strings?
Yes, all of the names have to be strings. Oh, no, they don't. Why did I say that? You can have anything. Okay. You can have this. That is fine. The criterion for something to be a legitimate name of a field in a dictionary is something we're going to talk about in the next course, in the Algorithms and Data Structures course. Is it hashable? We'll talk about what that means. For now, most things that are immutable can be what are called keys in a dictionary. So strings are okay, integers are okay, floats are okay, tuples are okay, but lists are not. And there was another question over there.
I'm
okay.
just wondering what can be keys, and I'm wondering about functions.
Yeah, so we'll talk more about that in the next course, but for now, let's just say most of the built-in immutable things are fair game, and that's honestly good enough for most of our needs.
Yeah.
Tom?
Yeah.
Tom?
Can you print the condos list again? I'm just curious how the 5 fits in now.
Absolutely.
Okay. Thank you.
Yeah, and I could do...
So it doesn't even change it to a string, it just...
Correct, correct. And I could even do this, although, well, yeah. Any other thoughts about dictionaries?
Okay.
Yeah, what's your name?
Karan. Karan.
Karan?
Yeah. So basically it's a key value pair on which all the searches they have to be on key, not on the left.
Yes, it is a key value pair. So the terminology is that the thing on the left is called a key, the thing on the right is called a value. And when you search for stuff, you give it the key, and it either gives you the value or says error, because that's not, yeah. Okay, just a little, oh, okay, yes.
I'm wondering, can you destructure a dictionary in Python?
Can you
Destructure.
destructure it, like into a bunch of tuples?
In assignment. So like in other languages, you can destructure an object and assign the variables to values within the object. I wonder if that's available.
I didn't understand the question, so let's talk about it afterwards.
Okay.
Okay. So other thing I want to say is that this square bracket thing, there's an equivalent notation which is .get. So condo square bracket bedrooms is the same thing as condo.get bedrooms. The one place where I find myself using .get is that you can actually give it a default value. So the second thing is going to be used if that key is not present in the dictionary. So bedrooms is already there, so we're just going to get 2. But if I say number of fireplaces, it's just going to say unknown because I never specified the number of fireplaces. That's just occasionally convenient in the sense that it doesn't throw an error if the thing is not in there and just nuke your whole code. It just says here's some reasonable default. Like unknown is actually a reasonable default for this example. Karan.
So is it right to say in NoSQL each and every record is a dictionary?
Is it trying to?
Is it right to say in NoSQL DBs each and every record is a dictionary?
Yeah, so NoSQL databases, you will talk about that in block 3 in the databases course. Are a lot of them basically this? Yes.
Okay.
Yeah, very close relationship there. Okay. Yeah, so we're a low on time, so let's leave that for later, other than the fact that it's not working. Okay, so another thing is just here's like how to create an empty everything. So empty list, you can use list, open, close, and that just gets you an empty list. Or you can use just the square brackets with nothing in it, empty tuple, parentheses with nothing in it, empty dictionary like this, or parentheses with nothing in it. Why am I showing you this boring thing? It's because it's just a little confusing that this thing here is not an empty set, because you're used to sets being with curly braces, and then you're like, oh, I'll just not put anything in there. That'll give me a set that has nothing in there. But now the reuse of curly braces for both dictionaries and sets kicks in and messes you up. So if you want to make an empty set, just use the SET thing to make a set, because this is actually a dict, as we just saw. So, okay, really minor detail may come and annoy you one time, and then I can say that I said it. So, okay, conditionals. Conditionals, meaning if statements, show up in all programming languages that I've seen, and they allow you to basically branch your code and say, only do this piece of code if this thing is true. So here's a little example. This input function is just going to ask me something, so it's going to check if my name is Mike, and it'll say, that's my name too. And elif, meaning if the first one didn't trigger, let's try this next one, also called else if in other languages. Is your name Santa? That's a funny name. For those of you who don't know, the president of UBC's name is actually Santa. And then else, meaning if none of those things were true, here's this thing to do. So I can just run this and say Mike or Santa or something else. Yeah, so the main points to notice, if, elif, and else are the built-in keywords to use here. You put a colon at the end, and the thing between if and a colon, it is going to try to cast that thing to a Boolean, because it's expecting a Boolean there. It wants true or false. If it's true, it's going to do it. If it's false, it's not going to do it. In this case, equals equals returns a Boolean anyway, so there's no casting that has to be done. But if I did like if 7, which is not really recommended, but if I did if 7, it is going to try to turn 7 in a Boolean, and then you're left wondering, well, I can't remember what happens if I try to turn 7 in a Boolean. I'm pretty sure it actually turns it into true, and so it's just going to say that was triggering the first thing. So don't do that. Like, it's just gross, unreadable code. So make it something that is a Boolean. That's my recommendation 99% of the time, so that the person reading it, which may be someone else, your future self, etc., can just look at it and understand what you're actually trying to do. And so it would, of course, be useless but valid Python to say if true, and then it's just always going to do that thing. Okay, what else? So in most programming languages, there's some sort of curly brace type thing to say, here's the block of code that is inside of the if or whatever. In Python, it goes by indentation. So this indentation that I'm highlighting here is not just because I want my code to look pretty. It's because Python is actually looking at that and saying, oh, that's the stuff inside of the if. And if I did this, that's now a different program. Because when this last line was out, it's going to print nice to meet you no matter what. It's going to deal with the if, done, and then nice to meet you every single time. But if I indent it, now print nice to meet you is inside of the else. So if my name is Mike, it will not be nice to meet me. So the indentation is part of the program. It's not just like visual to make it look nice, and that is a huge departure from most programming languages. Questions? What's your name?
My name's Evelyn.
Evelyn.
With the squiggly zero, that's clearly a way to take what you input into the
Yeah.
print statement. Is that just like always?
The squiggly zero, honestly, you probably don't even need the zero. The squiggly zero is this format thing that we talked about earlier, where there were two ways of doing it.
Oh, yeah, okay.
Yeah. Name?
Gaurav.
Gaurav.
Yeah. My question is about that empty things we created. So is there any meaning of creating an empty tuple because it is not mutable? Is there use case very...
Why would you ever want an empty tuple is the question. Yeah, not that often. You might want an empty list though, because you will later be adding things to it, but it is possible. There was another question before. Oh,
I
sorry.
think it might be connected. So non-type, well, if it's not, it's considered as false, right?
Yeah, probably. But actually,
If something is a non or it relates to non, is it kind of true or false?
okay. Here is a suggestion. So, or a challenge for all of you. If you ever are about to wonder, well, what happens if I do this? I challenge you to not ask anyone and just go into your computer, type in Python and say, bool of none, because you have in front of you these amazing devices that are way better than me at answering those types of questions. And I know I'm being a little bit silly right now, but there's a grain of important truth to it in the sense that in order to be a very effective data science, you're going to want that habit of just trying stuff. And maybe it starts with trying bool of none, but then it turns into, let me try this algorithm. It might or might not work. Well, I can just find out. I have this device, and it'll tell me if it works. And how can I probe whether it worked or not? And you've got to get into that, in a way, kind of fearlessness of just doing stuff, even though it might make no sense. It might throw an error, but it's never going to blow up your laptop and send you to the hospital. So it's pretty safe, and I really think it's important not to put you on the spot, Serge, but I challenge you to try to answer those questions with your laptop.
I saw that might be interesting to everyone.
Yes, yes. So here we go. I think there was one other question. Yes, what's your name?
Victor.
Victor.
Is there a difference for the indentation if we use tabs or spaces?
Yeah, tabs versus spaces. So this is like the eternal nuisance of Python, which is that you can use, this is actually 4 space characters, but for those of you who don't know, there's actually a tab character. And depending on your editor, if you press the tab button on your keyboard, it may insert the tab character, or it may insert 4 spaces because it thought that's probably what you wanted. And then it's very annoying if you have one text editor, you write some code, send, someone else, or you on a different computer opens it up with another editor, and then you get this mix of tabs and spaces, and sometimes Python complains. I would say let's just not worry about it for a brief moment, because you'll be using Jupyter, and you can just press tab, and whatever Jupyter does, it's going to keep doing that, and so it'll all be okay. But yes, both are valid, and yes, it is kind of a pain. Okay. Right. So, if statements can also be nested inside each other. That's just saying if you get to this else part, then actually maybe you want to check something else. Does the name start with super? And if so, do this extra thing that is now double indented. So that's only going to happen if the else triggers and then the second if triggers. And so you can try that out. Since there's a lot of SAMs here, you can do SAM. But if you do super SAM, then you get this extra line of code triggering, which is called nesting. It's like an if with inside of an if. And again, all that flow is determined by the indentation. Inline if else, this is just like a little convenience that Python offers you for a rainy day which is that you can actually do single line if else's if you want to get fancy. So this says assign to the variable x long list if this is true, which in this case it's not because there are 4 words in the list, else short list. So when I run this, x is now going to be a string, either the string long list or the string short list. And you could write the exact same code. So here it is. You could write the exact same code and say, if this is true, x equals long list, else. It's the exact same. There's a minor reason why I prefer the first one, which is that if I'm just looking at that, I know after that line of code finished, something got put inside of x, either one thing or the other. Whereas if you're dealing with big pieces of code and you do it the second way, and there's too much to read, and maybe x actually never got set to anything in the else side of things, and so I don't know, whatever, it doesn't really matter. They're both valid.